We are going to begin a unit on circles by initially discussing some basic terms. The essential question for this lesson is, how do you define a circle and a sphere, and what are some terms related to them? So let's start out by defining what a circle is. A circle is a set of points in a plane at a given fixed distance from a given point in that plane. I'll repeat. A circle is a set of points in a plane at a given fixed distance from a given point in that plane. Now, the given point is the center of the circle, and the given distance is the radius. Now, any segment that joins the center to a point on the circle is called a radius, and all radii of the circle are congruent. So let me repeat for one last time. A circle is the set of points in a plane at a given fixed distance from a given point in that plane. The given point is the center of the circle, and the given distance is the radius. And finally, any segment that joins the center to a point on the circle is called a radius. All radii of a circle are congruent. Now let's assume that we've got a circle. Now this is a rather crude-looking circle, but we have some more definitions to talk about. First of all, we know what a diameter is, okay? A diameter is a line that goes through the center of the circle and touches both ends of the circle, okay? That's the diameter. Now, a diameter is a very special chord, okay? And when I say chord, I'm talking about C-H-O-R-D, okay? Now, a chord is a line segment whose endpoints lie on a circle. So, there is a chord. The endpoints lie on the circle, and it's totally contained within the circle. A diameter, as you can see, is a very special chord. It's a chord that goes through the center. Now, the next thing we're going to talk about is a secant. Okay? Now, those of you that are a little familiar with trigonometry might think of the trig function called secant, but this is something totally different. Okay? A secant is a line that contains a chord. Okay? Remember the difference between segment and line. So a secant is this right here. A secant basically cuts through the circle, okay? So it doesn't stop at the circle, it cuts through it. So that's what we refer to as a secant. Remember, a chord is a line segment whose endpoints are on the circle. A diameter is a special chord that goes through the center. And a secant is a line, not a segment, that cuts through the circle. Now, our last definition of these types of lines is a tangent. Again, not to be confused with a trig function called a tangent, okay? This is something totally different. A tangent is a line in the plane of a circle that intersects the circle in exactly one point, all right? So it's going to look like this. It's a line that basically, and I didn't quite make it, but basically touches the circle in one point, okay? Doesn't cut through the circle in 2 points, it just touches the circle in 1 point. And that 1 point is referred to as the point of tangency, okay? So we've got chords which are totally within the circle, whose endpoints, it's a line segment whose endpoints are on the circle. We have a secant, which is a line, not a segment, a line which cuts through the circle. And then we have a tangent, which is also a line, but it only touches the circle in one point. Now, remember in our essential question, we said we were going to define a circle and a sphere. Well, we haven't talked anything about spheres yet, but what is a sphere? A sphere, put very simply, is a three-dimensional circle, okay? The proper geometric definition would be a sphere with a center and radius is the set of all points in space at a distance equal to the radius from the center, okay? So it's a three-dimensional circle. It's a ball, if you will, like a basketball or a beach ball. Now we have some additional terms. For example, congruent circles are circles that have congruent radii, okay? So two circles are congruent if their radii are congruent. Now concentric circles are circles that are in the same plane and have the same center, but different radii. So circles that are in the same plane and have the same center but different radii are referred to as concentric circles. Now lastly, we have the term inscribed and circumscribed. A polygon is inscribed in a circle, and the circle is circumscribed about the polygon when each vertex of the polygon lies on the circle. For example, this red triangle is inscribed within this black circle, or the black circle is circumscribed about the red triangle. Now we are going to talk specifically about tangents and the properties of tangents and some theorems and corollaries that relate to tangents. Remember, a tangent is a line that just touches a circle in one and only one spot. Now, this section starts off with a theorem. The theorem is theorem 9-1, and it states, if a line is tangent to a circle, then the line, that line that we drew that was tangent, is perpendicular to the radius of the circle drawn to the point of tangency. Now this picture right here illustrates this theorem perfectly. Shows we see a circle, we see a tangent, and it touches the circle at point A, and then we have a radius going from the center C to the point of tangency A, and we see that angle formed right there is a 90-degree angle. Now there's a corollary that follows directly from this theorem. Now this corollary simply states, tangents to a circle from a point are congruent. Okay? Basically what this is saying is that tangent to a circle from a common point outside the circle are congruent. So if you look at the diagram here, or the figure, we've got a circle with the center at O. We have two tangents from point B. Point and tangencies are A and C. Now if this is true, then we can deduce from this that the length AB, or the segment AB, is congruent to the segment BC. Okay, so this is the corollary that we're talking about here. So we've got another theorem here, theorem 9-2. This theorem states, if a line in the plane of a circle is perpendicular to a radius at its outer endpoint, then the line is tangent to the circle. It's sort of like the converse of 9-1. So again, we can use the same figure that I used before, except now we're going to talk about having a radius, CA, and a line perpendicular to the radius at its outer point, then we know that that line, in this case the blue line, is tangent to the circle. Now let's talk about some more definitions. A line that is tangent to each of two coplanar circles is called a common tangent. Repeating, a line that is tangent to each, a single line, but it's tangent to two coplanar circles is called a common tangent. Okay? Now, there are two types of common tangents. There are common internal tangents and common external tangents. Now, a common internal tangent intersects the segment joining the centers. So if we look at our figure here, and if we were to draw a segment from O to O prime, we would see that L1 intersects that. So L1 is a common internal tangent. Okay? So L1 is a common internal tangent. Now, a common external tangent, on the other hand, does not intersect the segment joining the centers. So in our diagram, L2 would be a common external tangent. So L2 is a common external tangent. Now, there are three problems here I'd like you to do. I have three sets of circles, two separate circles, two tangent circles, and two intersecting circles on numbers 1, 2, and 3 respectively. I would like you to answer how many common external tangents can be drawn to the two circles, and then how many common internal tangents can be drawn to each pair of circles, okay? So I want how many common external tangents can be drawn for these sets of two circles, and then how many common internal tangents can be drawn. And post your answers in the drop box. Thank you.